So we're going to go through a couple of examples of solving free fall motion problems. First thing that we want to start to do is pick and choose the information that we have given to us. I find it beneficial to draw a little picture of what's going on to help you organize your thoughts. So an apple drops from a tree, meaning that it starts at the top. So my initial velocity is going to be 0. Gravity is what's pulling me down, and it wants us to find the speed just before it hits the ground. So we must be looking for our final speed. And they tell us that our time is 1.5 seconds. So we have an acceleration of negative 9.8. We have, our initial velocity of 0. Our final velocity is what we're solving for. Our time is 1.5. They haven't given us a displacement, so we're going to ignore that for the moment. By knowing what they don't give me, it helps me pick out an equation. So the only equation that I have that does not have displacement is going to be one of our original acceleration equations, final minus initial over time. Then I can simply start plugging in my information as I go. So my acceleration is going to be my negative 9.8. My final velocity is what I'm looking for. My initial velocity is 0. My time is 1.5. Then I'm ready to solve. Always start by cross multiplying when we have a fraction and solve forward from there. I'm just going to help everybody set up the equations because that seems to be where we have the most issues right now, and then we'll kind of work forward from there. So for our next problem, we're going to refer to that same question above, and we're going to determine how far the apple falls. Far refers to the displacement or the distance. So we still have all that same information. Our initial velocity is 0. Gravity is the thing that's pulling me down. Our final velocity would occur at the very end, and then it's taking us 1.5 seconds to make that happen. So I have my acceleration, my initial velocity. We have our final velocity from the previous question, but because I found it and I may have messed up, or just in case, I'm going to try to ignore that as much as I can. I'm going to keep using the information that was given to me in the problem or that is fairly constant. So here I have acceleration, initial velocity, time, and displacement that I'm sure of. I'm ignoring that final velocity. So the equation that does not have final velocity would be our displacement equation. The initial velocity times the time plus 1/2 acceleration time squared. So I'm going to do my displacement equals initial velocity times time plus 1/2 times my gravity times my time, and I want to make sure I don't forget to square that time. Then I plug it in the calculator, get a simple answer. For our next problem, we're going to drop a pencil. So again, by dropping that pencil, that tells us that our initial velocity is 0. It's falling to the floor because of gravity. So our acceleration is at negative 9.8. In the question, they've now told us that we're going 1 meter. So that's going to be our displacement or our distance. And they want us to find how long. Long refers to the time. So they haven't given us a final velocity. They haven't asked us to find a final velocity yet. So I'm going to ignore that. And in doing so, I'm able to pick an equation. The equation that does not have final velocity is going to be that equation that we used in that previous question. In our notes, we've discussed the fact that that equation can be rewritten for finding time to save us a little bit of algebra, where the time that it takes for something to fall is 2 times the distance divided by the acceleration. So I am going to do square root of 2 times 1 divided by my 9.8. I'm using a positive 9.8 here because time has to be positive. Can't go back in time, positive only, so I'm going to use that positive value for 9.8 to get a positive answer. Number 4 asks us to refer to the same question that we just did. So we still know our displacement is 1. We still know that gravity was accelerating it. We still know that because it was falling, the initial velocity was 0. And this time they're asking us to solve for how fast. Fast would be our final velocity. So now I'm going to ignore or solve for, ignore the time because again, I may have messed up in my previous question. So the equation I have with these 4 letters in them would be my acceleration is equal to the final velocity squared minus the initial velocity squared over 2 times the distance. So my acceleration is negative 9.8. My final velocity is what I'm solving for. My initial velocity is 0. My displacement or my distance is 1. Combine like terms. So 2 times 1, well, that's just 2. 0 squared is just 0. So I can ignore that part. Again, always start by cross multiplying once you've combined your terms. And I'm writing this one out because I want to show that in this problem, our x is being squared. So the only way to square root in order to get rid of that x. So the square root is the inverse of squaring. I'm falling down, so I am going to get a negative answer when I do that. All right. For our next one, a squirrel drops an acorn. So again, by dropping that acorn, I know that my initial velocity is 0. An 18-meter tall tree, that's a displacement. It's falling because of gravity, so I know I'm going to use my negative 9.8. And they ask us to solve for how fast. That would be a final velocity. So again, I don't have time. I'm going to use the exact same equation that I did in my previous question. Final velocity squared minus initial velocity squared divided by 2 times the displacement. I should solve this one the same way that I solved the previous one. All right, let's set up a couple more. What is the vertical distance? So we're solving for that distance, that displacement. That's something that is dropped. So by dropping it, I know that it starts at rest, and I know that I'm using my acceleration of gravity, and it falls in 12 seconds. That would be my time. So I've been given a displacement, acceleration of gravity, velocity, and time. I have not been given a final velocity. So I need to use an equation that does not have final velocity. The equation that does not have final velocity would be displacement is the initial velocity times time plus 1/2 times the acceleration of gravity times the time squared. For number 7, using most of the same information, so I still know that my acceleration of gravity is negative 9.8. I still know that I am starting from rest, and I still know that my time is 12 seconds. This time they're asking us to find out how fast it's going. So we're solving for the final velocity. So in this case, I'm going to ignore the distance from the previous question because I may have made a mistake. I don't want to compound that error. I don't want to use that number. So the equation that I have that does not have distance would be final velocity minus initial velocity divided by time. And then I can solve. How long will it take for a water balloon to fall 25 meters? So meters would be a displacement or a distance. How long refers to the time that it takes. I'm falling, so when I fall, my initial velocity is 0. I'm falling because of gravity, so I've got my negative 9.8. So I need an equation that has initial velocity, gravity, time, and displacement. So off of my formula chart, it would be this one. And again, in our notes, we've simplified this for the time to fall is the square root of 2 times the displacement divided by the acceleration. Both of these should be able to get me to the same answer. Okay, remember that 0 times anything is 0. So that beginning of part cancels out. And I'm left with 1/2 AT squared if I choose to use that equation. So I'm going to refer to that question above. So I'm still going to use my initial velocity of 0. I'm still going to use my acceleration as negative 9.8. I'm still going to use my displacement as 25 because that was given to me in the actual sentence or the actual stem. And this time they want us to find how fast, so we're solving for the final velocity. So they have not given us time, and I don't want to use the time from the previous question just in case I made a mistake. So I have 2 velocities, acceleration and displacement, then my equation must be final minus initial divided by 2 times the displacement. Okay, and I want to make sure I don't forget the squared. It's probably the most common error is forgetting to square, or in this case, square root at the end. Next up, we're going to find the speed. So that will be a velocity type question. Required to throw a ball straight up into the air and have it return 6 seconds later. That would be a time. So I'm going to throw it up into the air and have it come back down. I know that at the top, my velocity is 0. And we want to know what speed we have to throw it in order to make that happen. We know we have gravity pulling us down, slowing us down. And of course we have our time. Now, I'm going to cut my picture in half because I know what the velocity is at the top. I want to be able to use that as my final. If I'm cutting my picture in half, I need to cut my time in half. So it's going to take me 3 seconds to get to the high point and 3 seconds to get back down. So when I solve my problem, I only want to use the 3 seconds that it takes me to get to my highest point. So this is the information that I'm going to use. I don't have a displacement. So because I don't have a displacement, I'm going to avoid using an equation that needs displacement. So if I have velocity final of 0, I have my acceleration of gravity, negative 9.8. I'm going to use my time as 3 seconds. I can figure out my initial velocity. The equation that has these 4 letters would be acceleration is final minus initial over time. If I want to figure out how high something goes, I'm solving for the displacement. So now I have the final velocity, I have the acceleration of gravity, I still have my time, and I want my displacement. I'm going to pick an equation that doesn't have that second velocity. So my equation would be my velocity times my time is 1/2 AT and squared. In this case, I can make this my final velocity. The reason I'm going to make it my final velocity is if I use the initial velocity, it would tell me that I went up, let's say 10 meters. So I can use my final velocity, and it's going to tell me I'm going to go down by 10 meters. So I'm going to rise the same amount that I'm going to fall. I'm going to start at the same speed over here as I would finish over here. So we're essentially taking this problem and now only focusing on the second half. So because of those similarities, even though it says initial velocity, recognizing that we have the same thing happening on both sides of the arc, we can interchange those parts. So my final velocity, or my velocity up at the top, is going to be 0. It's still going to take me 3 seconds to get down. I've got my half times gravity, and then my 3 seconds squared. If you don't like this rule about using the final velocity, we did find the initial velocity just a second ago. We could use it. I'm not a huge fan of using that number because of the fact that we may have made a mistake. But if we're fairly confident in our work from the previous question, then I could use it. I could use the initial velocity and still solve and get the exact same answer. So I could use my initial velocity from up here times my time. I'm only going to use my 3 seconds because that's the time to the highest point. So that's going to be 3 seconds to the high point. For a freely falling object dropped from rest, so our initial velocity is 0. What is the instantaneous speed at the end? So I'm looking for a final velocity of the 5th second. So that would be my time. Again, I'm falling, so I know that my acceleration is gravity's negative 9.8. So I have 2 velocities, a time, and acceleration. I don't have a distance. The only equation without a distance in my formula chart would be final minus initial over time. Hoping these are getting easier to set up, so I'm going to start to speed up a little bit through them and more just providing some keynotes. Next one, what is the acceleration of an object at the end of the 5th second? So if I'm falling, my acceleration at the top is negative 9.8. My acceleration at the next point, still negative 9.8, still negative 9.8. So at every point on my path, my acceleration is going to be negative 9.8. Gravity. It's a constant. I cannot change it. So next up, we have resting, an initial velocity. We have meters, a displacement. We want the speed, our final. And we are falling, so we know that we have gravity. So we have 2 velocities, a displacement, and our gravity. I have no time, so the only equation without time would be final squared minus initial squared divided by 2 times the displacement. Next up, a bird drops a branch. So our initial velocity at the top is 0. It reaches a speed of 35 meters per second, so that must be my final velocity. Just before hitting the ground, how high is the bird? And of course, we know if we're falling, we have our gravity. So we have two velocities, an acceleration and a displacement. Nowhere have I been told anything about time, so the only equation without time would be the one we just used earlier. Our final squared minus the initial squared divided by 2 times the displacement. A fish jumps out of the water. So this time we're jumping up. My velocity at the top is still going to be 0. But because I'm finishing up here, I'm going to call that my final velocity, whereas throughout most of this lesson we've been calling it an initial velocity at the top. But I'm finishing at the height. And it jumps where it breaks the surface, or it starts at 5 meters per second. How high, that'd be a displacement, can it jump before gravity, or 9.8, takes over? So two velocities, an acceleration, and a displacement. Again, no time. So my equation would be final minus initial squared divided by 2 times the displacement equals my acceleration of gravity. Alright, next up, a ball is thrown into the air by a boy. So I've got my boy. I'm throwing a ball into the air. It leaves the child's hand at 19.6 meters per second. And it travels a displacement of 19.6 meters. What is the final speed of the ball? So, up at my highest point, what is my final speed? Right away I know that my final speed at the high point is going to be 0 because gravity's pulling on me. It's slowing me down a little more, a little more, a little more. And eventually up at the top, we have to stop for just a second, which allows us to make that turn around and start to fall. So as a rule, my velocity at the highest point at the top is going to be that 0 meters per second. Alright, lastly we're going to look at just some conceptual questions, some rule-based questions as a quick review. So, air resistance. Air resistance is the thing that is holding us up while gravity is trying to pull us down. So if air resistance is holding us up and gravity is pulling us down, those two are going to be working against each other. They're going to start to try to cancel each other out. As a result, that would decrease our air resistance. It would be our acceleration. It would be less than 9.8 if we included air resistance. As a ball rises, it's going to get slower and slower and slower. That's happening because gravity is pulling on it. Every single second, it's going to lose 9.8 meters per second. Every single second. So what is the change in speed? Every single second, we're going to lose, and we're going to decrease by that 9.8. And that's why we use that negative. So we're going to lose 9.8 meters per second each second. Next up, we're going to toss a ball upward again. As it comes down, so as that ball falls down, it's going to speed up. So as it speeds up, that's occurring because gravity is pulling, 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 making me get faster. So every single second, gravity is going to increase my speed by that 9.8 meters per second. So gravity has that value of 9.8 meters per second squared, meaning that it increases our speed by 9.8 meters per second every single second on the way down. Because it's down, that's why we typically have that negative on the acceleration, on that gravity. So that down is what gives us our negative there. As a rule, when you throw something up into the air and it comes back down, so I'm getting slower and slower and slower. At the top, the slowest I can go is 0. And this occurs so that I can, in that split second, inertia is taking over. So we've canceled out everything, and now we'll start to get faster and faster and faster. But at the very, very top, as a rule, our velocity is 0, where inertia is the only thing acting on the ball. The ball is thrown straight up. What is its acceleration at the top? So even though it's not moving up and it's not moving down, gravity is still pulling on it. It's still keeping it from going. So we've got the kind of inertial force that's pushing up. We've got that gravitational force that's pulling down. And so we cancel those out at the very top, and that's what gives us that velocity of 0. But our acceleration is gravity. Gravity is always a constant value, negative 9.8 meters per second squared. I hope these notes helped. You need to make sure that you're able to label this information, determine when our velocity is 0, what our acceleration is it rising, is it falling? If you can do that, then it is very easy to pick and choose the equation, at which point it becomes algebra, which you've all been doing since at least your freshman year.